Hi everyone, welcome back to another video in our Ethereum series. In this video, we'll understand transactions in detail. So transactions on Ethereum are cryptographically signed instructions from accounts, which simply means whenever you want to do some kind of activity on Ethereum, you prepare a set of instructions that I want to do this, this, and this. Let's say you want to transfer some Ether from your account to another account, or you want to uh, call a function on a smart contract. So you basically prepare a set of instructions that, yes, I want to do this activity on Ethereum network, and you sign it using your private key. So that becomes a transaction request. So an account will initiate a transaction request to update the state of the Ethereum network. The simplest transaction on Ethereum network is transferring Ether from one account to another, and it roughly costs somewhere between $1 to $2 on good days. On bad days, it can be like more than the amount that you are trying to transfer. Now, contents of a transaction contains many fields. So we'll go through those fields one by one. One is from, that is the sender's address. This is going to be only an EOA address, because if you recall from our previous video about accounts, only EOAs can create transactions. Contracts cannot create transactions. The second is the to field. To field contains the receiving address. If this address is an EOA, the transaction will transfer the value from the sender's address to the receiver's address. And if this receiver's address is a contract account, then the transaction will execute the contract code. Then we have a signature. This is an identifier of the sender of the transaction. You basically use your private key to create a signature so that the network can verify the sender. Then we have nonce. Nonce is a sequentially incrementing counter, which usually indicates the transaction number from the account. Then we have value. The value field contains the amount of ETH to transfer from the sender to the recipient. This is denominated in way and usually stored as an UINT256 value. Then we have input data. Input data is an optional field to include arbitrary data. This usually contains a message to the smart contract that points to the function that will be executed. So if you are initiating a transaction that tries to do some activity using a smart contract, you will actually be specifying what function you are calling, what are the parameters that you are sending, etc., etc. All of that is included in the input data. And if you are deploying a smart contract, then the entire smart contract code is sent as the input data. Then we have a gas limit. Gas limit is the maximum amount of gas units that can be consumed by the transaction. So if you are creating a transaction and you don't want to overpay for your transaction, like an example that I have taken again and again, a simple Ether transfer should cost you anywhere between $1 to $2. But if the congestion is high on network, then it can end up costing you somewhere between $50 to $100 in very worst cases. So you might want to cap that gas fee out. Another example is where you are executing a smart contract code and you don't know what the code is going to do, but you don't want to overpay for the activity that you want to do. So you can limit the amount of gas, and if the gas used reaches this amount, the transaction will fail. Then we have max priority fee per gas. This is the maximum price of consumed gas to be included as a tip to validator. And we have max fee per gas. This is the maximum fee per unit of gas you are willing to pay for the transaction. This includes the base fee per gas set by the network and a maximum priority fee per gas. I guess I'll leave this at this for now because we have another video covering gas in much more detail. So you can check that out for what the priority fee means, what the base fee means, and I'll move on to the next section of this video. So all of these fields about a transaction, you can check them out on Etherscan. You can go to any transaction on Etherscan. Let's say, let's pick a latest transaction from Etherscan, and you can see that it has a transaction hash, it has a from field, a to field, value, transaction fee, gas price, etc. You can also see input data here. So that's how you can check out different transactions happening on Ethereum network, and each transaction would vary based on the activity that the user was trying to do. So do check out a couple of different transactions, and try to find out the differences yourself. Okay, now we'll talk about the type of transactions that can happen on the Ethereum network. There are three main type of transactions. One is regular transaction, which is a transaction from one account to another. This is a simple EOA to EOA transaction where one end user can send or receive tokens or ether from another account. The second type of transaction is contract deployment transaction, where the user tries to deploy a smart contract on the network. In this transaction, there's no to address, and the data field, as I already mentioned, it contains the contract code. The third type of transaction is execution of a smart contract. This is when a user tries to call a function on a smart contract deployed on the network to carry out some kind of activity on Ethereum network, let's say swapping a token on Uniswap. This is a transaction that interacts with the deployed contract, and in this case the to address is the address of the smart contract. Okay, so we have discussed enough details about a transaction. Now, what is the entire life cycle of a transaction on the Ethereum network? So there are four main stages to the life cycle of a transaction on Ethereum network. The first stage is a transaction hash is cryptographically generated using the transaction data, and it will look something like this. The second stage is when the transaction is broadcasted to the entire network and it is added to a transaction pool where all other pending network transactions are also there. In the third stage, a validator picks up the transaction and includes it in a block to verify the transaction. If the block is verified, then the transaction is considered successful. And in the fourth stage, as the time passes, the block containing the transaction will be upgraded to justified and then finalized. When the block and your transaction within it is finalized, it makes it much more certain that your transaction was successful and will never be altered. The only way it could be altered is by creating a network level attack that would cost many billions of dollars. So, again, recollecting from my blockchains video, the system is designed in such a way that economically it won't make any sense for you to hack the network and change the previous data. Instead, if you use the same amount of resources and contribute to the network, add your own node or validator, you will end up making much more money than that. The last section of this video is about type transaction envelope. So Ethereum is an open protocol that keeps undergoing constant updates, and at one point community needed support for multiple types of transactions that allow for new features such as access list and some other EIPs to be implemented without affecting the legacy transaction formats. So when Ethereum was created, a simple transaction format was created, but as the network will keep on upgrading, you might want to have different transaction format that are much better suited for certain specific operations. So EIP 2718 is what allows for this behavior. In this, basically, the transactions are divided into two parts: transaction type and transaction payload. The transaction type is a number between 0 and 0x7f, and it creates a total possibility of 128 types of transactions. And whatever follows that is a transaction payload, which is an arbitrary byte array defined by the transaction type. So whenever this transaction would need to be processed, the first few bytes of the transaction would form the transaction type, and using that type you'll know how to understand the raw transaction data, because the data would be formatted in a particular way. Like we discussed that a transaction has a certain number of fields and each field would represent this. So different kind of transaction formats could have different kind of fields in different orders. So using the transaction type number, you know how to process the raw transaction payload. So one new term that we encountered here was EIP. EIP stands for Ethereum Improvement Proposals, and there are multiple EIPs under work, and some of them have already been implemented. So, in a nutshell, each EIP is a way to add some new functionality to the network or fix some old problems. And the core idea is to keep evolving the Ethereum network so that it works better for all of us. So each EIP introduces a particular kind of feature, and I'll have a complete series of EIPs where we'll discuss each EIP in much more detail. So it will soon be live. And that was all about transactions. In the next video, we'll cover blocks.